This is KBYP's video on some interesting features in the Yaesu 857, which has been largely ignored because much of my life in the past 3 years has been taken up by the TR3 and the TR4 being little monsters. So, first trick, enter the service setting by turning the power off, holding A, B, and C buttons down, pressing power until you hear a click, release it, you'll hear a diddle 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 tone. Adjustments 24 through 44 are for transmit power levels. This radio is sent out with a decimal value of about about 120 some. Here it's set at 255 there, but the radio is sent out with a decimal value of something more like 120, which is about 100 watts peak in transmit on phone and basically CW. This is a mobile radio primarily. This transmitter can be turned up to almost 200 watts peak. And pay no attention to those who say it will damage the finals, because it will not, and this is proof right here that it won't. I got this from a ham in Illinois who operated CW Mobile with one of these at 200 watts and said he'd done it for 6 years. If someone tells you it will damage the finals, ask them, what is the dissipation rating of the finals in that radio? Not only will they not know, but they won't know what dissipation rating is. And it's 260 watts RMS. Turning this up to 200 peak is only about 100 watts, so there's not a chance in you-know-what that's going to damage the radio. Just don't run a lot of SWR. But we shouldn't do that anyway. The power levels can be turned up by going to adjustment 24. Turn this knob to change the adjustment number, adjustment 24, and turn the big knob to change the decimal value, 250, 240, turn it all the way up to 255. As you turn up through the adjustment numbers up to 44, you'll see HF1 power out mid 2, mid 1, minimum. I set minimum at 0 to go to QRP, HF band 2, HF band 3, 50 megacycles or 6 meters. Then there's VHF and UHF. I wouldn't turn the VHF and UHF up. If it's that bad, get an outboard amplifier. But this makes a big difference on HF. Don't mess with other settings in here, especially the final current and the sideband receive levels and such, unless you first write down the decimal values, because this thing can be thoroughly messed up by changing these levels and not being able to put them back. To escape this mode, hold the function button down. Here in CW, listening to the CW signal, see the green power light flashing blue? That means the receiver is tuned in so that the tone frequency is the same as the CW side tone frequency set in the function settings. That's obviously an easy to hear signal. Occasionally, you might be sitting on 7005 listening for DX and that light will flash. That means the receiver's picking up little snippets of a signal that I can't hear. That means there's somebody in the background. Just wait, they might come up out of the noise. These are the carrier shift settings. Carrier, lower sideband receive, transmit, upper sideband receive and transmit. This is in CW receive. Now hold on, maybe it's USB. Hear the difference? Going to the plus side tends to make it appear that the tone goes lower. That's doing essentially a passband shift. You got to watch doing this in receive, because it can make other stations appear to be splattering in the wrong sideband when they aren't, or aren't as much as they really are. So use it judiciously. The carrier and transmit can be shifted to accommodate low-pitched voices, such as I have, to bring the voice closer into the passband of, well, it would be a digital filter. There's no analog filter, but into the passband, the sideband filter. And I've tested this on the air and gotten reports that it makes a considerable difference. This is a transmit IF filter. It's set to non-applicable or C filter. I turn it off, it turns itself back on. I don't know why. If anybody figures it out, let me know. Here's the CW pitch setting. It's at the lowest setting, 400 cycles. I like it even lower, but I can't get it. This is for the tone for CW, obviously. If we exit that menu mode, invoke the function, and tune up to a little thing called spot, and push the button, it emits that 400 hertz tone. And the purpose for that is to be able to hold that down and turn the VFO to align that tone with the tone of the sending station that we're listening to, to in theory put the transmitters on the same frequency. This spot has a very useful other purpose. Let's say that you want to align a piece of equipment on 10 megahertz. Tune WWV in. In fact, let's go to WWV on 10 megahertz. Okay, there's Fort Collins. There's Fort Collins on lower sideband. Not coming in too well, but there it is. If we couple a signal from an external source at 10 megahertz into here, we don't hear a tone. We might hear the background noise change a bit as a WWV carrier and the signal being coupled in change phase or change frequency slightly. But the WWV signal is not constant, and it's really difficult to beat this together. The trick is to go up a few hundred cycles and listen and get a tone difference of the signal we wish to test against WWV up here a couple hundred cycles, and push the spot. Hold the spot down. See, hold the spot down here. Nothing happens on the Yaesu. But adjust the signal to be calibrated so that its tone is the same as the spot tone. And that is the same offset for both signals because it's an offset in this receiver. But it's not a zero beat exactly. It's the tones being equal. But that means that the signal being tested is also on the same frequency as WWV. Long control cables on the Yaesu need to have ferrites clamped on the outside. Real good thing to have. Good to keep the cable length short. There's one there. There's one on Mr. Microphone. And if you turn the power up on this transmitter, realize that this 30 amp MFJ switching supply, which works reasonably well, is pretty much at the end of its limit when this radio is at 100 watts. Turn it up, the power supply voltage will dip. So to deal with that, I put a storage battery back here in parallel with the power supply and put an electrolytic capacitor across the power supply leads to provide a little more surge current. If you do turn the power up, take the control head off the radio. Don't leave it on because these vents in here are where the cooling fans draw air in, and let's just don't push our luck. It doesn't cost anything to take it off. Also, the fans in there are very noisy. You don't want that on the bench because you'll hear the fans. The Yaesu and CAT operation, I designed and built a CAT adapter with a cable to plug in the back of the radio. And I used YO3 GGX as software on the smartphone. Be careful. I was able to get this radio receiving in 2 different bands at once. I don't know how or why, but that's not supposed to do that. The Yaesu meter has SWR function. Leave it on SWR. It'll be interesting to note that if we're following the illusion of thinking that that's an antenna tuner, and it is not, in most cases. In this case here with my antennas it is, but there's a trick there that's not obvious. But you'll notice that the SWR reading on the so-called tuner meter and this meter are almost always different. And that's because of the excess cable length between the so-called tuner and the radio. And that indicates that even if one or the other appears to be a 1-to-1 SWR, it isn't. because if it was and the feed line were resistive and flat, it would read the same SWR everywhere, and that would be 1-to-1. You've probably heard of doing the modification to wideband this radio. I did it. It works. Be extremely careful with the circuit board. It's very delicate. Widebanding the radio is obviously against FCC regulations. There's an interesting use for this, and that's to make a high-powered RF signal generator, which can be divided down with a resistive divider to a node that's a purely resistive signal. And that's a whole lot cheaper than a real RF generator, which are $5,000 to $10,000. And back in here is the factory Molex 110 thousandths power connector. Those terminals are rated at 10 amp. 2 of them are 20 amp. They're underrated for the radio. So be careful. If they get old or running higher power, those terminals may fail. The blob of tape back here hides a reverse polarity protection diode. Great big heavy low voltage high current rectifier backwards across the power line. You do not want to hook this thing up backwards. And also don't exceed about 15.1 volts on DC because it can do damage.